Right, so this is for some surface mount components. You see I have a little PCB here. This was actually a redesigned PCB for our C design project stuff. Didn't actually end up working. Don't really know why, 100%. Didn't really care. We moved on to other things. So most likely I'm gonna guess you're gonna work with some amplifiers. This is a voltage regulator. Here's another voltage regulator, and you got some pins and stuff. I guess I should probably actually show those, how I do those. I'll cut to that in a little bit. But so I'm really going to focus on the really difficult ones. I'll show amplifier, and then capacitors and resistors, right? So they come actually in a variety of sizes. I did not pay attention, and I ordered, just equivalent values. And this, if it can focus onto it, is the capacitor I had to solder. And you kind of see how small of it. I don't think it will focus. You can kind of see it, but you see how tiny that is. I'll just put on the board, or you can kind of see it right there. You see how tiny that is, right? Don't get those. They're a pain in the ass to solder. And then this is one of the resistors. Obviously, much easier to solder, much bigger. However, it's a tiny too big for my designed PCB. So that's also another thing to watch out for. Kind of compare if you design PCBs, buy the right size one. They're all really cheap. Resistors, capacitors are extremely cheap. They're like pennies for packs. So normally you buy them in like 50 to 100 packs and for a couple bucks. But the way I solder these before, I didn't use flux. I'm actually going to use the resistors only because I am not going to deal with the capacitors right now. I'll just solder a couple resistors and show how I do that. Bye-bye capacitors. So I normally originally never used flux. After when I started using flux, it did make it a lot easier. So in this case, you probably want a little thing of flux. These aren't too expensive. It's like $8 for 2-pack. And then some pliers to hold on to your parts. These are plastic. Hopefully they don't melt. The metal ones I normally use, I don't know where they are. And I don't feel like wasting any more time finding them. So the way I normally do it, once again, I have my little wire solder. I have my soldering iron. What I'll do is sometimes I'll actually just put a little bit on the soldering iron. See the pad where you want it to be soldered onto? One of the pads, I'll do a little dab on it. So there's a tiny bit of solder now on that, right? Tiny little bit of solder. I'll take my component, heat up that solder again, and kind of just slide it on, right? If it actually slides on. I'm working at an angle, so it's a little hard for me to see. Normally it's like I do top down, but for camera. So you basically just slide on one, right? So this isn't coming on flat. It's annoying. It's actually not sticking at all. I actually don't think I have enough solder on there. Or that's not the right pad. I don't remember. There we go. So you see how that's stuck now. And now I would go on the other side and solder. So because this resistor is obviously way too big for these pad sizes, it's a bit of a pain. It's not the greatest demonstration of this, but you can kind of adjust it, heat up one side, and then you can go on the other side. Then you can just heat it up. You heat up the other side, and then kind of same concept, but this is actually where I'll kind of do the heat the soldering iron, put the solder on the soldering iron rather on the component, and then kind of like allow the soldering iron to then wick it onto the component. So then, the solder would transfer onto the pad. But obviously because the pad's way too small for this resistor, it doesn't work. I don't remember how I exactly got it. I think I kind of have them a little bit higher up, so there's space for me to kind of put it on. I'm gonna get a better component and see if I can properly show that. And then I'll also get an amplifier, because these are kind of a pain to do because there's such little tabs for each one. But honestly, they're not the worst. And I also demoed the soldering iron pump, and then also one of these through-hole connectors. All right, so these are actually some of the amplifiers. They're at 8623. Surface mount. So you can have like surface mount or through hole. So you see they're really tiny, not really tiny, but like they're smaller. It's gonna be hard to depict it, but normally how you differentiate like where top is on them. Let's see if it will focus. It's not gonna focus. All right. Well, you see on the PCB, there's like a dot, and on the actual amplifier, there'll also be a dot. So on the actual amplifier, there's like a tiny dot in the corner. On this one, normally there's either a notch or some sort of dot signifying what quote unquote top is. And you can like look at the pinout. All right, so first we'll do one of the properly sized capacitors. So you see this one's slightly larger than the smaller one, also smaller than the actual resistor. So this one will fit a lot better. So hopefully I can do this one properly. Concept wise, there's also obviously, actually we're gonna use a little flux on this one, right? So dab a little flux on this, put it on the pad. This is probably really the only time I'll really use flux. Kind of heat up the pad, or I'll dip the actual PC component into flux, right? Get that pad heated up, add that solder. If it will actually stick, that's the one thing. Sometimes it won't really stick well. So here you can see that I got a little bubble, little dab of solder on there. So now I'll go back. Sometimes it helps to have a clean soldering iron tip. I'll just heat it up, put the component on there. And you see that's it's on. Nope, it's not on there actually. I don't think there's enough solder. It's hard for me to see right now. Oh, that solder's not actually melted. That's why. So this is actually why I normally have my soldering. It's like cranked up really high heat so I can get this done really easily. You're just gonna have to sit here, watch me struggle. I'm not sure why that's not heating up properly. Hold on. Let's go ahead. Oh. So normally if you have it flat, I'll just like kind of shimmy it on so it's level. But because we're working at an angle right now, why won't this connect? There we go. So that's basically the concept. Application is a little difficult, but I normally just put a little dab, have some, melted solder on here. It's gonna dry, right? It's gonna solidify, but then I essentially will reheat it with the soldering iron and kind of move on to the little component onto it. Once that's secured on there, I'll go on the other side and then apply the solder that's needed. So heat it up, and then have the solder kind of together, because it's not really going to melt unless everything kind of heats up together, right? So once you see it melt, got a little dab, that's it. I would be careful though, because some of the smaller ones, if you heat it up for too long, the whole component will heat up enough and both sides of the solder will melt. But that's just how I do it. It's probably not the best way. Obviously if you bake it or something, it'll be a lot cleaner, a lot easier, but that's how I've always done it. Now for the amplifier, it's the same concept. Get a little solder, kind of put it onto one of the little pads, only one of them, right? All right, you see I got that on there. Take the amplifier, or whatever component you may use that has legs on it, right? Heat that one up. Wait for it to heat up, melt down. Right, it's melted down. Put it on, line it up. Right, try and get it. I think this is where the flux could come in handy. You would dip like some of the legs in the solder, or in the flux, and then you wouldn't have this issue of trying to heat shit up. So the solder on my soldering iron's dirty. I don't think I actually put enough on here. to really have it stick. No, I didn't. All right, so we're gonna set that there. We're gonna try again. It is trial and error. I got pretty good at this when I was doing it a whole bunch, but so now I got a little bit more on there. Basically just slide the leg on while it's melted. If it gets melted, it's not melting. It's not like melting all the way. Right, so now, boom, it's on there. So this is the more difficult part of essentially getting solder on every single leg to connect it without getting solder between them. So heat up both and kind of put the solder on it. You really only need a tiny bit. So sometimes I'll also just get solder on the actual soldering iron, put a little dab, and then that's good enough. Go to each leg, kind of give them a little dab of solder. Now, in the event you do get solder on 2 of them, right? So let's say, oh, oopsies, I put too much solder, and look, now they're joined. You don't want that, obviously, because now they're shorter to each other. This is where your soldering iron pump comes in handy, right? You depress it so you can have that vacuum. You heat up that solder, all right? Once it ever heats up, heat up that solder, get your soldering iron pump. You kind of want to basically right over it, and then boom, you suck it up. You might have to do this 2-3 times, but you see how that basically cleaned up that join connection, all that excess solder and stuff. You can also do the thing what I was talking about where you have the clean soldering iron and it'll kind of wick away some of it, but sometimes I think it's really messy if you really have too much. And some of the in-between like connections, you really got to heat up. There's also like soldering wick pads, which I have, but I haven't really been able to use them very successfully. It's been very hit or miss. So I'll do it one more time. Get this to its like liquid, put it over, suck it up. And then from here, you can kind of just clean it up. You see, it's basically 3 small. So for the last thing, we have through-hole connections. So obviously you see how they have through-hole. You kind of slide these in. These are a lot easier. So all you're essentially doing now is putting solder down the hole, essentially. So I might put one, like heat up one, and kind of put a little dab so it sticks onto it. But what I normally do, once I get this to kind of go, right, so put a little solder on there, right, put it through the connection. So now it's kind of like a placeholder. I'll flip it around, and this makes it a lot easier to just make sure this is angled well. You can kind of see the little holes here. Just heat it up and put your solder there and wait for it to melt. Because once everything's hot, nice and hot, it'll kind of just funnel in itself. See, it's now hot enough. So now I can just basically put the solder on and it'll basically take. And you see how it basically just funnels into the hole once everything is warm enough. So if it's too cold, the solder will just stick on the top. And that just means the top part in the soldering iron is hot enough, but the whole like component throughout isn't. So the solder's just going to pull the top and not flow through. But once everything's warm, you see you put the solder in and the solder will naturally just kind of dissipate. And then we'll go back to our placeholder one, heat that up, wait for that to heat up. I see the solder actually that I already put there melted a little bit. Now we can go ahead and put extra solder, secure it down. It's all kind of nice and clean connection. And we'll go back, look at the top. So you see maybe a little too much solder, so it kind of came through too much. But it's a really clean connection. And you know it's a good connection throughout because everything got hot. And the solder basically would travel against the hot, or whatever is heated up, right? And not pull. So now that's how you do a little through hole connection. You could clean this up or you just, dab a little bit at a time. and then just kind of check and make sure it's not too much. I put way too much for just for fun, but that's the basics to that.